Good morning class. Today we will discuss about enzyme catalysis. Before coming to this topic, let us recall what we have studied earlier. So we have studied about what is adsorption, what are catalyst and catalysis, their classification based on mechanism and based on their physical state. Now let's talk about enzyme catalysis. But before coming to this topic, let us see some more topics which are left. Here you can see that is catalytic promoter or promoter. So what are they? So substance which itself do not act as catalyst. These substance itself do not act as catalyst but enhance the activity of catalyst. Okay, and these are termed as promoter. You can say catalytic promoter or promoter. Why? Because it promote the catalyst. Okay, so generally promoters are used in heterogeneous catalysis. Here you can see the example, that is N2 react with H2 and gives NH3. So for this Fa is the catalyst. Okay, and molybdenum here is act as promoter. So as it increases the catalytic activity, that is why it is called catalytic promoter. Now you can see the second topic, that is catalytic poison or poison. So from the word it is clear that it may be harmful. So substance which either decrease or completely destroy the efficiency of catalyst are called catalytic poison. You can again see the similar example, that is the production of ammonia. Here N2 react with H2 and forms NH3. What happens here? F is act as catalyst, but when we add carbon monoxide and H2S, then it act as poison for the catalyst. That is, they decrease or completely destroy the efficiency of catalyst. Okay, now you can see the very second example. Here you are seeing the production of sulfuric acid from contact process. So here also SO2 react with O2 and form SO3. Here platinum act as catalyst, but when arsenious oxide is added, then it act as poison. That is catalytic poison. So this is about catalytic promoter and poison. Promoter is one which enhances the activity of catalyst, and poison is one which destroys the efficiency of catalyst. Now there are some more type of catalyst, that is shape selective catalyst. What are they? Whenever you will hear this name, that is shape selective catalyst, you will also recall about zeolites. You have also seen that in your 7th 8th classes that they are used to remove the permanent hardness. So that zeolites are called as shape selective catalysis. What happens here? Catalytic reaction that depend upon pore structure of catalyst and size of reactant and product molecule is called shape selective catalyst. Its best examples are zeolites. You can see here zeolites. So they are good shape selective catalyst because of their honeycomb like structure. Okay, so their example are Linde A, JSM5, etc. Let's talk about their uses. So they used in isomerization, in petroleum industries, and in cracking of hydrocarbons. So used of removing permanent hardness. As discussed earlier, they are used in removing permanent hardness of water. And what is permanent hardness? It is simply the mixing of chlorides and sulfate of calcium and magnesium in water. Now students, there is also one more point left before dealing to enzyme catalysis, that is important feature of solid catalyst. We have earlier discussed about solid catalyst. So what is their important feature? There is two features of them, that is activity and selectivity. So let's talk about both. What about activity? The activity of catalyst is its capacity to increase the speed of chemical reaction. Activity will what it will do? It will increase the speed of chemical reaction. Here you can see it will increase the speed of chemical reaction. But what about selectivity? Its ability of catalyst to a reaction to yield a particular product. Okay, suppose we are reacting A plus B and it will form C plus D, and we have to obtain C in more, okay, in larger quantity. So here we will use the selectivity criteria, that is that type of catalyst which direct reaction to yield a particular product, and here our particular product is C. Okay, so now we will discuss about our topic today, that is enzyme catalysis. It is very important. Almost every year or alternate year question are directly asked that what is enzyme catalyst and catalysis, and give the mechanism of enzyme catalysis. So let us study. Enzymes are non-living nitrogenous and proteinous complex organic compound having high molecular mass. What I am saying, enzyme are non-living nitrogenous and proteinous complex organic compound. Okay, they have high molecular mass. Students, in general, enzyme catalyze biochemical reaction. Generally you see enzymes like lipase, amylase. What do? They catalyze biochemical reaction inside our body. So thus they are also known as biochemical catalyst, because they perform functions in our body, biochemical functions. That's why they are called biochemical catalyst. Now the most important thing, that is the mechanism of enzyme catalysis. So its mechanism is simply given by lock and key method. Many theories were there, but the lock and key method was broadly accepted. So here in this mechanism, what happens? Michaelis and Menten proposed the following general reaction for enzyme catalysis. This is the general reaction where E plus S gives ES and result in P plus E. What these symbolize? Here E is enzyme and S is substrate. So when they combine together, then they form an intermediate that is called ES. Okay, and after this they result in formation of product, and enzyme is released as it is. So this is about the Michaelis-Menten equation, and this is also referred in the sense of lock and key theory. What this theory says, according to this theory, the shape of substrate and enzyme are complementary to each other. What it says? It says that suppose here is the enzyme and we are reacting it with the substrate. So the shape of substrate and enzyme are complementary. Complementary means they will fulfill each other. So if they will be opposite, that they bind together. Okay, suppose if I can say the enzyme is like this, then substrate will be like this. This will fit into it. Okay, here you can again see, here you are seeing this is the enzyme and this is the substrate, and you see here blank spaces here where the substrate will fix itself and form a intermediate complex. This is called ES. Okay, and which decomposes. This ES decomposed and result in formation of product and enzyme. Okay, product, enzyme and enzymes are formed in free state. So this is all about today's lecture. Let us recall what we have studied. So we have studied about enzyme catalysis. In this we talk about some terms, that is catalytic promoter, catalytic poison, selective catalyst, that is zeolite, and we also have discussed about important features of solid catalyst, that is their activity and their selectivity, and we studied about enzyme catalysis. Okay, for this we have studied the mechanism of enzyme catalysis, that the equation given by Michaelis-Menten, and also the lock and key theory, where substrate combined with enzyme result in formation of a intermediate complex, and the intermediate complex decompose to form product and enzyme, okay, in free state. So this is all about today's lecture. Thank you.